Alrighty, boys and girls, welcome to our next video lesson in Chapter 6, Lesson 6-5, our lesson on the properties of logs. Okay, let's review for a minute what is a common log. A common log is log base 10. So a log base 10, x. Okay, we can just write that. We don't write the 10, we just assume it's there when nothing's there, so we can write log base 10x. That's just log x. And a natural log, of course, is log base e of x. Well, we don't write log base e, we just write natural log, which we abbreviate as ln x. That means log base e. Okay, you guys try these right now. Just see if you can answer questions 1, 2, and 3. And I'm going to give you a little clue. There is one you may have a little bit of a problema with. Go ahead and see if you can figure out what each of these logs are. I shall be right back. Okay, you should have found that the first one is 4, because 3 to the 4th power is 81. You should have found that the second one is 3, and again, remember this is a common log now, so this means log base 10. 10 to the 3rd power, of course, is 1000. And this guy, log base 5, so 5 to what power is 85? Well, I don't know. That's one that we can't do without a calculator, and even with a calculator, you don't quite yet know how to do it. But I'm hoping you arrived that it's going to be 2 point something. And I know it's 2 point something because 5 to the 2nd power, 5 to the 2nd power is 25. And 5 to the 3rd power is 125. And notice now that 85 is somewhere in between 25 and 125. So this value must be somewhere between 2 and 3. So in the first two problems that we just did, when we did log base 3 of 81, 81 is a power of 3, so we knew that our answer is 4. And the second one was a common log, log base 10, which is of 1000. 1000 is also a power of 10, so that we can know without 3. If the log of what we're taking is a perfect power of the base, then we can do it without a calc. But when you look at your calc, folks, there's only two logarithmic log buttons on your calc. There's log, which is our common log, and there's ln, which is our log base e. Of all the other logs, where the base is not 10 or e, you need to use the change of base rule to figure out what our answer is. And for that, you're going to use the formula log base a of x is equal to log base b of x divided by log base b of a. And we will derive this formula in class, but you're going to use this now because you can use as your log base b either common log or a natural log. So if I want to know what log base 7 of 14 equals, I want to know what that is. Okay, I want to know 7 to what power is 14. Well, I'm hoping you're all saying right now it's somewhere between 1 to 2. It's somewhere between 1 to 2 because 7 to the 1st is 7. And 7 to the 2nd is 49. So log base 7 of 14 is going to be 1 point something. But we're going to use our change of base rule, and we're going to do log 14 over log 7, where my base b, for both of these, I'll just use a common log because I have that button on my calc. Notice now 14 is on the top, and the 7, the one that's lower down, is on the bottom. So log base 7 14 becomes log 14 over log 7. Go ahead, folks, whip out your calcs and see if we can come up with an answer. Okay, if you did log 14 divided by log 7, you should have gotten 1.356. The beauty of this is if you do ln 14 divided by ln 7, you're also going to get 1.356. Okay, you guys try this one on your calc. Use your change of base rule to get log base 6, 71. We wanted to know 6, I need my marker. 6 to what power is equal to 71? Go ahead, use your change of base, and I shall return. Okay, you should have gotten 2.379, and we know that makes sense because 6 to the 2nd power is 36, And 6 to the third power, you guys know this, it's on your powers table. 6 to the third power is 216. Notice that 71 is in between 36, 6 to the second, and 6 to the third, 216. Alrighty daddy, these are our 3 more properties of logs, and they're probably our most important props. The first one is called the product property of logs. If I take the log of a product, so in other words, log base b of x times y is equal to the sum of the logs, and that's because, remember, logs are just exponents, and if you multiply exponents, you know that you add the individual exponents, okay? So log base b of x times y is equal to log base bx plus log base by. The quotient property of logs, in other words, if I take the log of a fraction, log base bx divided by y is log base bx minus log base by. And if I take the log of an exponent, so log base b of x raised to the n power, this is called the power property of logs, is n, you bring this n down in front, it's n times log base b x. So this is our product property, our quotient property, and our power property of logs. Okay, so if I say expand this log, we're going to write this out in more than one log. We're going to use we're going to start by using our product property. So I'm taking log base 3 of 4 to the second times 3 to the fourth. So what I'm going to do here is I'm going to rewrite this as log base 3, 4 to the second, plus log base 3 of 3 to the fourth. I'm now going to use my power property of logs. I'm going to use my power property of logs, and I'm going to bring these exponents down in front. So I get 2 log base 3, 4 plus 4 log base 3, 3, and I'm not quite done, because if I look right here, I see a log base 3, 3, which using my inverse property, I know that log base 3, 3 is 1, so this whole thing right here just becomes 1. So what I have here now, and I'll write this in, let me choose a color, red, rojo, I have 2 log base 3, 4 plus 4 times log base 3, 3, which is 1. 4 times 1, which is 4. Okay, this next one, we're going to use our quotient property. I'm taking the ln, the natural log of a quotient. So we're going to rewrite this as ln 6 minus ln e squared. Okay, there's nothing I can do with the ln 6. But now the ln e squared, I can use my product or my power property of logs and bring this 2 down in front. So I have ln 6 minus 2 ln e, and once again now I can use my inverse prop of logs when I do that's equal to 1. So ln e is just 1 because e to the first power is e. So I have ln 6 minus 2 times ln e. Ln e is 1, which then becomes 2. ln 6 minus dose. Okay, you guys are going to try this one on your own, but before we do, I'm just going to rewrite, see where we have the square root of x squared plus 1. Let's make that a little bit easier, and let's think of that as ln of x over x squared plus 1. Square root is to the 1/2 power. So you guys use our quotient property. Start by using the quotient property to simplify this. Okay, you should have gotten as your final answer ln x minus 1/2 ln of x squared plus 1. Because we used our quotient property first, we have ln x minus ln of x squared plus 1 raised to the 1/2 power. I then use my power property, bring the 1/2 down in front. So I have ln x minus 1/2 ln x squared plus 1. Now be careful here. There's nothing we can do with this. This is not the ln of a product. Okay, this is the ln of a sum, so we just got to keep this the way it is. This is not equal to 1/2 ln x squared plus ln 1. Okay, so that's our final answer. Okay, now we're going to go the other way. We're going to do what's called condensing. We're going to condense, so we're going to take what is a difference of two logs with the same base, so I can use my quotient property to rewrite this as log base 5, and they must have the same base of 8 over t. In other words, I went backwards. As opposed to making things bigger, I made them smaller. I condensed it. Okay, and we're going to condense this last one too. We're going to condense this last one where I have 3 ln's, but before I do, I'm going to actually just distribute this 4. So what I have here is I have 4 ln z plus 4 ln in parentheses z plus 5 minus 2 ln z minus 5. I'm now going to use my power properties and my quotient properties, but let's do the power properties first. I'm going to move the exponents back up top. So move those 4's back up top and move the 2 back up top. So I have, in other words, let me get a marker, switch colors, ln z to the quattro plus ln in parentheses z plus 5 to the 4th minus ln z minus 5 squared. And now I'm going to use my product property to condense those. So I have ln of z to the 4th times z plus 5 to the 4th. And I'm going to use my quotient property because I'm going to subtract now. Use my quotient property, and that's the ln of those divided by z minus 5 squared. And I'm actually just taking the ln of that entire thing. That's it, folks. That's all she wrote. That's a good one. We'll talk to you soon. Adios.